Hello everyone, welcome to our channel Mathematics Parshala. This is a problem of CSIR UGC NET Mathematical Science June 2023. The question ID is 704076. This is a problem of linear algebra. Let us now try to solve this problem. See here, a linear operator T from R3 to R3 given that it's satisfying this equation pq minus 3t square minus 2i, where I is the identity transformation from R3 to R3. Then which of the following statements are true? R3 must admit a basis B1 such that the matrix of T with respect to B1 is symmetric, and like that all those options. So let us now first analysis this portion, that an operator T satisfying this equation. That means what? So see, suppose lambda be an eigenvalue of this operator, then there exists some x non-null vector such that our Tx equal to lambda x. That means our t square x equal to t lambda x equal to lambda tx equal to, if we put lambda x in the place of tx, we get lambda square x. And similarly we get tqx equal to lambda qx, and if we put the value here then actually we get t cube x minus 3t square x minus 2i x equal to 0. That means we get lambda cube x minus 3 lambda square x minus 2x equal to 0. That means lambda cube minus 3 lambda square, uh, sorry, this will plus 2i. So this is plus 2 into x equal to 0, and since this x is non-zero vector, so this scalar must be 0. So lambda cube minus 3 lambda square plus 2 equal to 0. So that means if lambda is an eigenvalue of this operator t, then lambda must satisfy this equation. So let us now first factor this equation. uh, Clearly 1 is the factor of this, and just you solve by yourself. The simple verification, this will be actually our lambda minus 1 into lambda square minus 2 lambda minus 2 equal to 0. Vanishing method, like that you can solve this. Then we get actually this is our lambda minus 1 and lambda minus, the roots are 1 plus root 3 and 1 minus root 3 of the second factor. So this is 1 plus root 3 into lambda minus 1 minus root 3. So see, there are three distinct roots of this equation. So now suppose the given this polynomial is, uh, we denote this by f lambda. This is our lambda cube minus 3 lambda square plus 2, and let us denote chi t lambda by characteristic polynomial of t, and m t lambda by minimal polynomial of t. Let us denote this by, okay. Now see, this f lambda, this f lambda actually annihilates t. So this is annihilating polynomial of t, and we know that a minimal polynomial divides any annihilating polynomial of t. So we have this mt lambda divides this f lambda. So now let us write all the possibilities for mt lambda. So see here, first let me write all the possibilities for mt lambda. So one is, first say mt lambda is, we are writing here mt lambda, and corresponding chi t lambda we are writing here. So first of all, mt lambda may be lambda minus 1, and then this chi t lambda, so that means 1 is the only eigenvalue of t, so chi t lambda must be, since t is an operator on R3, must be lambda minus 1 এর whole cube. Number 1. Number 2, empty lambda may be only lambda minus 1 plus root 3, that means 1 plus root 3 is the only eigenvalue of t, then this characteristic polynomial should be lambda minus 1 plus root 3 whole cube. Exactly in similar manner, empty lambda may be only lambda minus 1 minus root 3, and this is corresponding lambda minus 1 minus root 3 whole cube. Number 4, empty lambda may be product of any two, so lambda minus 1 and into lambda minus 1 plus root 3. So in this case, there are two possibilities for chi t lambda, because there are two eigenvalues of t, 1 and 1 plus root 3. So maybe like this, lambda minus 1 whole square into lambda minus 1 plus root 3, and also lambda minus 1 into lambda minus 1 plus root 3 whole square. Exactly in similar manner, if we take empty lambda is lambda minus 1 into lambda minus 1 minus root 3, there will be two possibilities for this chi t lambda. Let us, we are not writing this, exactly in similar manner we get, and this is also the similar one. If lambda minimal polynomial is lambda minus 1 plus root 3 into lambda minus 1 minus root 3, exactly in similar manner we get two cases for chi t lambda. Number 7, maybe f lambda is the minimal polynomial, that means this. So in this case, this is actually our f lambda, in this case chi t lambda must be same, so this is the case of all the possibilities for minimal polynomial and the corresponding characteristic polynomial. So look at this, the cases for minimal polynomial. In all the cases, minimal polynomial must be product of distinct linear factors, because it divides the minimum, it divides that polynomial f lambda which is also the product of distinct linear factors. So in any case, empty lambda minimal polynomial is product of distinct linear factors, and hence t is diagonalizable. That means diagonalizable means there exists a basis, say beta, such that the matrix of t with respect to this beta is a diagonal matrix. So now look at option 1 and 2. See, option 1 says that R3 admit a basis such that the matrix of T with respect to B1 is symmetric. So we get basis B with this, the matrix with respect to that basis is diagonal matrix, so that must be symmetric. So option 1 is correct. And option 2 says that a basis exists, the matrix of T with respect to that basis is upper triangular, so we get diagonal, that must be upper triangular. So option 2 is also correct option. Now look at option 3 and option 4. See, we have written all the possibilities for empty lambda and chi t lambda. So if we look at option 6, so if empty lambda is this, so 1 is not an eigenvalue of t, so in chi t lambda 1 also will not appear. So as 1 is not an eigenvalue, so now look at option 3 and 4. Option 3 says that R3 must contain a non-zero vector V such that T V equal to V. It means that 1 must be an eigenvalue of T. But in case 6, uh, T uh, may not have eigenvalue 1. So option 3 is not a correct option in general. And also look at option 4. R3 must contain two linearly independent vectors v1 v2 such that tv1 equal to v1 and tv2 equal to v2. That means also 1 must be an eigenvalue of t, but in case 6 1 may not be an eigenvalue of t. So option 4 also is not correct option. So here option 1 and 2 are only the correct option, and option 3 and 4 are not correct option. Okay, we meet in the next problem again. Thanks for watching.